I'm sorry, the computer is still booting because that's where we have our lectures. Urbanization and challenges for freshwater ecosystems. We're going to have a case study of pollution on Auburn River, and then we're going to see how freshwater systems are managed, and then we'll have the second case study, which will be a guest lecture on Salford Keys. So basically, from all what you have been learning, you're looking at human impact on the biosphere. This particular one is going to focus on urbanization. So you're going to see a cascade of information that not only, limits your knowledge and scope from what you are learning, but it expands it beyond what you are learning, so that you have a broad perspective in terms of maybe policy relation activities or maybe legislation like that, and how these relate to freshwater ecosystems. So these are for the next 4 lectures, today and the next 4 lectures, that's finishing on Monday next week. These are what you will learn. So that at the end of this lecture today, you should be able to identify some challenges to freshwater ecosystems and should be able to explain the impact of these challenges to freshwater ecosystems using case studies. So for the next few lectures, for the next few slides, I would like you to concentrate on what what examples I have, so that we can have an understanding when you are asked, you'll be able to write based on some of these things we are going to discuss today and in the next few lectures. So urbanization is no longer new to us. Some of us come from countries where we have a high level of human growth. So in places where we have high level of human growth, China, Africa, and some other parts of Asia, human population has continued to increase. But then there is one concept of human population. There is also the concept that people are moving from rural areas to urban areas. So if this is happening, what it invariably means is that there will be a resource overuse. And so what we have here is that we are not unaware that global population is more than 7 billion, and this is set to increase. And then we know that people are migrating, and this is being forecasted to increase by 60% in 2030. What this means is that if urbanization is being extrapolated to increase by 2030, it means that the resources we have now is going to be overstretched. So there is a concept that we may not have enough for the future generations. And that is why, if you're looking at it, what it also invariably means is the fact that our resources are going to be stretched. If a sewage treatment works is designed for 100,000 people, with an influx of people into urban areas, the sewage treatment works is going to be stretched. And that means there is an impact on biodiversity. So if this is the case, there are policy discussions globally where we have discussions, like the recent meeting on climate change, the recent meeting on, global meetings on climate change, global meeting on sustainable development, is looking to help us to understand what are we going to do, how can we sustain our resources. We know that we say development is the one that meets, sustainable development is the one that meets the needs of the present without compromising future needs. But how can we sustain our freshwater resources, which we know, some of us have learned it in our second year, that freshwater resources are less than 0.1% globally. So if this is the case, you need water for many things. I need water for things. There are so many resources, so many ecosystem services that water serves us. Even economically, water serves us. What are we going to do? So this is a global issue. The more people move into urban areas, there is a tendency that there is a need for people to use resources. You use water, domestic issues, you use water for sanitary issues, you use water for so many other things. So how is it that if our fresh water is not managed, how does fresh water undergo and manage, how does it perform its regulatory service? How does it treat water? How does it dilute effluents? So these are some of the things I want us to know, and we are going to look at it, using our case studies. So the particular Sustainable Development Goals that actually focuses on water quality is the UN Sustainable Development Goal 6. So it is for us to know. So in other words, the challenge of freshwater resources is not only a UK problem, is not only my country's problem, it's a global issue. And why, we will see. This is the this is the map produced by the World Resources Institute. I'm sure some of us here, we can identify where our countries are here on the map. And then you see that areas that are kind of yellowish, so those are areas that are low risk. And then the ones that are kind of a deeper yellow is low to medium stress, about 10 to 20%. But then if we look at areas that are red and deep red, we see that the level of stress is quite high. And look at those countries there. How many of you can identify here? Here. Australia, very good. So there is a tendency that water is going to be a problem. And then where else can you identify from the map over Africa there? Huh? Do you know where you come from? Serious question, isn't it? Maybe you know where you come from, but you know, the places up, where do you think, you know, the places, the deep red or above, above the map that is shaped like a comma. The one that is shaped like a comma is Africa. So where do you, above that, where else do you think that water is going to be a challenge? And it's already a challenge in some parts of the world that there are conflicts. Where do you think these are? Who comes from that area? Do you know the area? Huh? Okay. Where else again? In North Africa, there is going to be a problem. In some parts of the US, there is going to be a problem. There was already a problem whereby in Sacramento, in the California area, there were already a challenge of drought. And this is going to be a problem because in areas where we are going to have a lot of water stress conditions, what it apparently means, there is going to be environmental migration. Because when there is no water, people are going to migrate from one point to another seeking water. So while we are having water stress by country, we also know that if our freshwater resources are to be sustained, we need to understand how we are going to protect our water. What are the implications for freshwater resources? So it is not just looking at the water itself, it's about what are the far-reaching implications in terms of sustainability. How do we sustain our food? Some of us, we depend on fish. We eat fish, we eat, some of the macrophytes are suitable for feeding. How are we going to sustain ourselves? And in places whereby there is not enough money, how do they survive to buy water? So these are some of the challenges I have here. We're going to have the issues of overexploitation, limited sewage treatment works to cope with the increased urbanization. That means there is going to be potential pollution. And then there are issues of pollution and disease, climate change, and conflict. I think sometime earlier this year, there was a production, there was the Northern Assets Water in the Northern Powerhouse, where they produced a document that here in this Manchester, in the northern part of the UK, there is going to be a challenge of water. In fact, one of the questions is, what is our future holding up for us? It says, there is considerable uncertainty in forecasting future water resources. Although the water industry has promised to reduce leakage, everyone must play a role in managing overall demand. In other words, we also need to change our attitudes to water. You are wondering why you are learning this as a biologist or as an ecologist or somebody studying pollution and environmental control. This is the fact that you need to understand these issues so that you have an overarching contribution when you secure a job or when you go into job spheres. All these, the issues of pollution is not devolved from the issue of management. It's not devolved from the issue of actually monitoring. It's not devolved from the issue of attitudinal change. These are social issues. So in other countries, you're going to see there is a challenge of drought. China and India already has a problem, with water pollution, water shortages. I think last year there were issues between some parts of China and Myanmar, where Myanmar has water. Myanmar is formerly called Burma. So they had water, and then the Chinese now created some kind of pipeline so that water transfers from Myanmar to China. But this is this is an issue because the Burmese are kind of looking at how can they really benefit, even though the majority of what they do is agriculture. And then you can see this picture here. I deliberately put it so that we can have an understanding that in some countries we're already buying water. And that means your finances will also translate into what you can have as a resource, including fresh water. In other words, what I'm doing at this moment is actually to make us think. Think that we are not devolved as scientists from the issues that bother us, from the issues that bother freshwater resources, the issues of urbanization. So, what are some of the challenges? We have urban water transfers. From this study of McDonald, they said in the US, about 4 in 5 urban cities will depend on surface water. That you're already beginning to know. And that means there's going to be a lot of pressure on public water supplies. If there is a lot of pressure on public water supplies, it invariably means there are some people that will have and some people will not have. So that means there is going to be a competition. And so in areas where there is water, they will have to transfer water from a distance to areas where there is no water. If you look at here, all the areas in blue are catchment areas where there is water. And then areas where there is no water are areas in brown. That means you'll be wondering that how is it going to be possible? It's going to be possible because the more money you have now, it's getting to the point whereby the more money you have, the more you can purchase a resource. So urban water transfers is going to be a problem. It's already a problem, but it's going to increasingly be a problem. So what I will want you to do is that following this lecture, you look through the McDonald's and see what are the challenges of urban water transfer and what are the issues. What are the issues and what are the expectations from that paper. And then looking at this one, we also have the challenge of water withdrawal. In the UK, we have the Water Abstraction Act. There is a regulation called the Water Act. It gives you the license to abstract a certain quantity of water from a place, either for the sake of businesses, in terms of maybe businesses that churn out effluent, or in terms of irrigation or any major water project. So here, the study here looked at a shift in the community composition from water withdrawal in a place in the US, in Oregon. So here, you will have on the green side, it says disturbance intolerance. There are certain pollution indication species. There are certain organisms that you will find in places where the conditions are favorable. If the conditions of the water is not favorable, what this also invariably means is that some organisms are going to die. You will find some that are tolerant of harsh conditions, some tolerant of good conditions. So for example, here we have the flathead mayfly. You will always find this mayfly in places where the conditions are good, where the physical chemical variables, the dissolved oxygen, the temperature, the nutrients are suitable, and so it will grow, and then it has good water supply, good flow. But in the circumstance whereby the water has been abstracted to the point whereby there is a lot of churning in of effluent, pollution, and there is no dilution, you are likely to find some organisms that are sensitive to stress, that are tolerant of stress, and such as this flatworm you found there. So here, if we look at this graph, if you look at the y-axis, you look at the relative abundance on the y-axis, and then the water withdrawal. What can you say from the graph here? Can anybody think of what the graph is showing us? What do you think the graph is saying? Or what are your ideas? What are your thoughts? You know, this is looking at the implication of water withdrawal on the biodiversity of a system. So what do you think this graph is showing us? What are you thinking? What does it say? ideas? Please, no wrong or right answer. Just say what you think, and that will be excellent. Yes. Okay. Yes. Yes, thank you very much, Elizabeth. Who else? That is very good. Yes. You know, in other words, we are beginning to. Somebody has opened the floor for us. Who else has an idea? Okay. Maybe this is what I should let you know. For the master's degree students, we're going to have some discussion session. But this is also part of when you are asked in an exam. You could be asked any questions, but you should be able to kind of identify things and as well as synthesize the information. So this is where we are. So please, everybody needs to kind of speak. We know that this, we said the green ones are the disturbance intolerant, you know, which means they are not, they don't mind being, you know, they can be sensitive to disturbance. And then these ones, they are adapted. So, and then you see the green bars. Does this say anything? And then the line there is the level of discharge. That is the level of flow over a period. Maybe over a cubic meter, over a meter, over a second, or a day, or a year. Anybody has an idea? Wow, this is now something. Is it, am I too fast? I'm too fast. No, serious, so that I can slow down. Is it too fast? Yes. Oh, sorry. Okay, now. You said the question is, what the, no, it's good. At least it's good for me to know. The issue is that, what is this graph telling us?
Well, that's basically some sort of critical point where Q is about 1 centimeter per second.
Okay.
And where it sort of massively changes.
Yes. Thank you very much. What else do you see? That is a very good point. And somebody there mentioned something very good too. So in other words, we have two pieces of, you know, analysis. What else can you see from that graph? Okay, can you see anything on that graph? Can you see blue? Okay, what does the blue mean? Huh? Huh? No, please speak. It will be good to hear your voice. Huh? Huh? No, well, you know, I heard somebody speaking, so. Well, it is telling us that, you know, with the blue, these are organisms that are tolerant of stress conditions. You will see that as the discharge is reducing, you will see that all of a sudden, you know, there is now an increase. But with the green one, in other words, species that are sensitive to disturbance, you will see that, well, it's been good, it's been good, it's been good, but then all of a sudden when the discharge decreased, we saw a reduction. What do you think could be causing this place? You can see there is a difference. There might be no significant difference between these bars, these 4 green bars. But what happened here? What do you think could be happening? I want you to apply all your learning into that question. Why do we, all of a sudden, from 1, 2, 3, 4 heavy bars, you know, about almost 60% relative abundance, 60–65% relative abundance, and then there is a sharp decrease to around maybe less than 20. What do you think could be happening? Because these are looking at implications. What do you think is happening there? Shall I give you an idea? Okay. Somebody saying something.
Loss of nutrients.
Okay, that could be one thing. Yes. But if there is loss of nutrient, what else do you think could be happening?
Competition.
Huh? Sorry, I didn't hear you.
Competition between different.
Competition, there could be competition for resources. Yes, that is a good one. Yes. What else? The discharge has reduced. So if the discharge has reduced, and we can see that there is a potential that the case in question is that there is a withdrawal. So if there is continuous withdrawal, I will bring you this, maybe here now. This is my pond or, a water body here. And I keep abstracting water. Okay? The more I abstract water, all those organisms that are sensitive to my conditions, flowing water, will be reduced. The relative abundance will go down. But what also happens that because this area is surrounded by a catchment, there is a tendency that as I'm abstracting water, suspended solids is increasing. When the suspended solids is decreasing, which is also one of the physicochemical factors, it will choke some of those organisms in that place. In other words, sensitive species will start dying out. And then tolerant species will start increasing. In a circumstance whereby there is contribution and the flow is continuously being withdrawn, there is a buildup of nutrient concentration. So if there is a buildup of nutrient concentration, what it apparently means is that some organisms will die as a result of high nitrate or phosphate. And then with the high suspended solids concentration. So if that is the situation, what else do you think could be happening to the physicochemical variables? Something like the dissolved oxygen might be reduced because the level of flow may have been reduced as well. I will want you to study this because I have only given you hints on how the physicochemical variables relate with the biology, with the biodiversity. Is that okay? I think this will be a full lecture if we go into it, so let's carry on. But I hope we get a bit of an insight into so many things I've said. So you look at how is it, what is happening during water withdrawal on freshwater resources, and that is why it might be very important for us to start looking why water abstraction for dam construction has to be managed. So, what are the implications of dams? When dams are constructed, of course, we know they're supposed to store water, and then there will be deposits of fine sediments onto the river substrate, leading to a reduction of flow. And then there could be challenges of decomposition of drowned vegetation. When there is a decomposition of drowned vegetation, like macrophytes, what do you think will happen to that water body? Or what do you think should be happening? We have a lot of macrophytes, the aquatic plants, they are growing, and all of a sudden, because of construction of dams, what do you think will be happening to the water? It's starved of oxygen, yes, thank you. So when it is starved of oxygen, what do you think will be happening? What do you think will be happening? It is actually here. It leads to a reduction of oxygen at the bottom waters. And when that happens, it means, what else do you think will be happening? When there is a reduction of oxygen at the base of water, what this will mean is that
No oxygen.
if there is no oxygen, what it means that what you said something.
Dead areas.
Oh, dead zones. Oh, sorry, I didn't hear that. So if we have dead organisms, if we have dead macrophytes, if we have reduction in oxygen, what do you think will be happening at the base? Is it going to be an oxygenated system or an anoxic system? Huh? It will be an anoxic system. So if we have a situation whereby there is no oxygen, the flow is kind of reduced, what else do you think will be happening at the base of the water? There is a tendency to release other compounds. Yes, there is, if a place where there is decay, there is reduced oxygen, what basically happens is that we are likely to have the production of hydrogen sulfide, which is the one that causes the smell. And so other other organisms like the hypomycetic fungi will start functioning in the water. So that water is being remineralized back to the surface of the water. There are challenges. And this will also lead to the introduction of pests and nuisance species, because those organisms, those plants or animals that are tolerant of such conditions are the ones that will thrive very much. Here it says high population densities of the filter feeding invertebrates. Filter feeders are some of those organisms that have the tendency to actually filter either sewage. They can feel, they are very comfortable when the oxygen is low, when there is sewage, like worms, like the non-biting midge larvae. Those are the types of organisms you'll find there. They are called filter feeders because they have structures that help them to filter the system. So it will be good for you to read that and also get some information. So in places like this, you are likely to find a loss of animals for more than half a kilometer, or almost 2 kilometers. This is another challenge. This is the challenge of over-abstraction of freshwater resources. I already mentioned that in the UK you have something like the Water Act that regulates what you should abstract. So industries have to actually sign up with the environmental regulators so that they are told how much water that should be abstracted. So basically what happened is that there used to be a lot of water here at Los Angeles. So Los Angeles River was the one supplying Los Angeles. But with the influx of people going into Los Angeles, what happened basically was that they now started using the water from the Owens River and the Mono Basin. So because of the continuous use of water, over abstraction of water, it now means that even though here sounds a bit like a wetland, if there was a lot of competition around that area. So with competition for resources, competition for physicochemical resources, it means the stage of the water will be depleted. So here we have a loss of riparian vegetation, we have a loss of fish species, and at the same time we have reduced water quality, which increase deposits of untreated municipal water. Any question? Is it clear? Is it unclear? Is it too much? No, it's good for me to know so that I scale down things, Is it too much so that if this information is too much, because basically I want you to read this so that you have your summary of what the challenge of over-abstraction of freshwater resources is. And when we talk about urbanization and water quality, this is already a challenge globally. There is a challenge to the flow, and most areas are impervious. If you go to most cities, most urbanized areas, they have impervious surface cover. Anybody has an idea what we mean by impervious surface cover? So that we know what we're talking about. Impervious. Impermeable, yes. Something that is impervious. If you look at on Oxford Road, it's good that we have some areas that are green. But if you see on Oxford Road, you will see the majority of some parts are concreted. Everywhere is concrete, isn't it? So because of that, it's an impermeable surface. And this is a challenge in most urban areas. So here we have that with urbanization, we're going to have increased runoff because we have here 75 to 80% imperviousness. So if that happens, we have shallow infiltration, about 15% infiltration, and then we have a lot of that runoff. And then we have 30% evapotranspiration. In a place whereby the areas are not concreted, we see that we have about 50% of infiltration and then about 10% runoff, and then evapotranspiration, 40%. Any wonder why people are agitating for having more green spaces? Because if we continue with this kind of system, increasing impervious areas, what do you think the implications will be? Number one, for our homes. Number two, for the treatment works. Number three, for quality of water resources. What do you think? These are three major areas.
Flooding.
Flooding, yes, very good. Flooding. When flooding happens, what do you think will be another implication? When flooding happens, what happens? If you are lucky that your house is not in a flood zone, you will not be flooded. What it invariably means, if we continue with this kind of system, there is a tendency that even the sewage that comes from your house to the treatment works, to be treated, will backflow into your house. I don't think we have the experience yet, especially most people, but most people, even in this country, are already facing the challenge. So these are the implications, and the issue is that if we have a degree of imperviousness as high as 100%, what do you think will happen to the biodiversity of water, to the biodiversity of rivers, of lakes, of water bodies? What do you think will be happening to them? You have your river. Some of us are very good at walking our dogs, at walking near water bodies. We receive the benefit of nice flowing water. We like the sounds. We like we like to, if some of us who have dogs, we walk them into the water. We enter the water, enter the sandy area, the stones, and all of a sudden everywhere is concreted. For some of us who do the kick sampling, we are able to see some organisms and we say, wow, this is beautiful. In a circumstance whereby everywhere is concreted, what do you think will happen to the biodiversity? Meanwhile, when I'm talking about biodiversity, I'm not just talking about the tiny organisms, I'm also talking about the entire food web implications. What do you think will be happening? It will decrease the abundance of organisms, yes. So let's say if it decreases the abundance of the benthic macroinvertebrates, I'm telling you, what will happen? What is the far-reaching implications for the food web? We all know the food web, isn't it? We have our fish, we have other provisions from water, isn't it? So if one is implicated, what do you think will be the long-term impact over the entire trophic status of freshwater resources? I think this is for us to think and to read and to make our own summary of the implications. And that is why this book and the paper by Paul and Mayer is very interesting, because it gives us a bit of an implication of the physicochemical variables in relation to freshwater resources. This is an information for us. It says over 100,000 kilometers of running water in the US is damaged by urbanization. What happens in China? This is it. So, this is interesting. And this one is looking at a study carried out by Luo et al., looking at the impact of rapid urbanization on a freshwater body. These people, they were looking to study what implications urbanization has. And then they looked at it from diverse areas. They looked at the land use, they looked at the physicochemical variables, they looked at the natural vegetation versus impervious areas, and then they looked at areas where the ecology has been degraded. And what they just did was to classify areas between the high, medium, and low urban areas to look at the various physicochemical relationships. Do we have better water quality with low urbanization levels, or is it with medium urbanization levels or high urbanization levels? And so they plotted the relative abundance in relation to the benthic macroinvertebrates. So we have the sensitive ones here and then the tolerant ones here. So in areas where we have high, you can see the green, high urban high urbanization level, you are seeing that there are more organisms. I can see the Tubificida, which is an oligokid, is a worm, and then we have the Chironomidae, we have the Hirudinidae, and then the Glossophoниdae. All these ones are leeches. And then looking at that, so it's giving us an indication of what they found in their study. There are so many things. They also even looked at the fact that they looked at the land use in that particular study. How does the land use impact on the state? So they looked at the various things. They looked at forested areas, grasslands, unused areas, and then the ones that was of interest was the one I brought out here, so that you can have an understanding. So they did a lot of study, and then they analyzed what the conditions could be. Of course, they said that the low urban areas, they were able to tell us that the urban areas, the highly urban areas, had more tolerant species. But for me to allow you to do some work on this, the people who are the MSc students, the BSc students will have to read the paper and answer the questions that I have given. That will be your assessment for this scheme. The master's degree student, you have an option to read it, but I will strongly advise you to read it. Any question? So, other issues. In 2018, there was this issue, there was a Guardian newspaper. Just to let you know that, the dailies, the media is another means where we get some information of what's happening. So there was this article that said why we shouldn't waste a drop of increasing water. It was written in July 2018. And this was at the period whereby they were really thinking of what could happen post-Brexit. I'm sure it doesn't sound so good when you are hearing post-Brexit. But the issue is that our management, the management of our freshwater resources is not devolved from the politics. And that is why you, as someone studying, you don't know where you are likely to find yourself and where you're likely to make decisions. So these ones are for you to know. And last year, there was a challenge of water, shortage of water last year somewhere in the north. And it was a major problem that we are beginning to see what could happen. And that was one of the issues that informed this writing from the Northern Powerhouse. This was in August 2019. Is it possible that we are going to start rationing water resources in the UK? Some parts of the UK are already having shortage of water, especially those in the Anglian region. Anybody from Anglia here? East Anglia, there is nobody. Those areas are really lacking water. In some parts, maybe during the summer, there were some parts that their lakes were dried up. And so there were a lot of studies there, and they had been on the implication of dry waterbeds to river biodiversity and lake biodiversity. So looking at that as well is when we are talking about urbanization. But it's interesting to know that even rural areas are having the challenge of reduced abundance of organisms. So what could be happening? So it was good for us to look at urbanization impact as a case, but there are also other issues in terms of low water shortages, other implications. So I'm bringing this to our knowledge. Steve Omerod is one of the foremost freshwater resources academic in this country. In an area that is continuously urbanized, you are going to lose riparian vegetation. And so when that happens, when there is a loss of food materials for organisms, what it apparently means is that there's going to be a reduced biomass. So I have kept that paper there for you to be able to have a look as well. What are the implications of having limited riparian vegetation and the impact on river biodiversity? So, we're in Greater Manchester. It is very interesting that this is a city. This is an urbanized area, and there are more people coming into Manchester on a daily basis. And that means the resources will continuously be used and overused in some parts, save for regulation that allows us to be able to control the use of resources. So this is interesting because I'm sure some of us have already gone through Manchester very well. If you've been here for 3 years or thereabout, you would have explored some parts of Manchester. And then you see that while some areas are still, with the water, the river meandering, you can see some areas are already so much straight. Is it possible to have a straight river like that? It is as a result of canalization. It's a result of other impacts on water. So what this means is that in a circumstance whereby we are having canalization, it also goes back to what sort of development has taken place. So the tributaries here, we have the Irk and we have the Medlock. So I'm going to give a case study tomorrow on the River Medlock, and then the next case study you'll have is on the Manchester Ship Canal and Salford Quays. I'm sure you can see some of the impacts, the combined sewer overflows. I'll show you, I think, a picture of combined sewer overflows. So in a system that has 513 combined sewer overflows, these are some of the barriers to biodiversity. So here is for information that in a, beg your pardon. In a circumstance whereby in 1840, this was the situation. But in 2016, we can see that the areas have been so much developed. So the challenge, we have decreased water velocity. And when water velocity decreases, it impacts on other physicochemical variables, which I have mentioned earlier. And Manchester has a lot of canals. As you can see, you have the Manchester Ship Canal, the Bridgewater Canal, the Rochdale Canal, and then here is going to be the focus of your study tomorrow. And then the case study will be here. And this is a major work in the UK where Kate White had contributed to in terms of managing the lake so that people can go there and have a good time as well. But the history was terrible. So the River Medlock is still being studied because there is not a classic way of saying what the issues are, even though we know that it was subject to pollution many years ago. But still the challenge is majorly phosphate at the moment. So, in terms of physicochemical variables, the water has improved. In 1930, it was within 10 to 20, but it's reduced to 5. Dissolved oxygen has improved. The quality is now moderate. These changes actually happened based on the Water Framework Directive, which is a regulation that was brought in by the European Union. So these are some of the challenges of the air well. However, there are still other challenges that are being investigated in terms of microplastics. There was a lot of study from Geography Department where they identified microplastics at the air well. But this is the subject of discussion for another day. In this case, we are looking at pollution. We are looking at urbanization on physicochemical variables. And talking about other issues, we have the combined sewer overflows, the canalization, and then the artificial banks. All of these impact on freshwater resources. So this is an example of a combined sewer overflow. They are only supposed to work when there is a lot of storm. So they serve with increased water flow as a result of storms. They are supposed to serve as a storage, so that after all the sewage coming from your homes, from the surface drains are collected in overflows. And then the people who manage the infrastructure are the water companies. So So they actually release them when the situation is okay, and then it can undergo dilution. But there had been a lot of studies to let us know that in some cases the overflows are also released in the absence of, when there was no need for that. Why it looked like a perception, because what also happened was that from the medlock here, there was a perception that the overflows were causing problems. But when I investigated it with other people, we realized that it was not 100% true. But the perception of people led to the study. So here, there is the discharge and the y-axis and then the date. This was measured as a result of a data logger that helps us to be able to measure nutrients over a period. So they measured the discharge, and then they found that the discharge, the river flow, contained, when there was no rain, when the discharge was low, the parameters were good, but when it was high, that was, the water quality was not so good. So this is telling us that the combined sewer overflows has an impact. This is a point source. But these are, you will not look at this on the basis of what you have seen alone. There are other contributory factors for us to help us to inform this kind of decision. So the same thing with wastewater treatment works. There are a lot of studies carried out by Bowen et al. Where they looked at what is pollution. When do we say something is point source pollution in an urban area, and when do we say something is diffuse source pollution? So in this case, you can see that the concentration of phosphate is high here, but with increasing discharge, there is a bit of, there is reduced phosphate concentration, indicating that this is dilution taking place. But in a circumstance, according to them, when the graph is going the opposite way, it's telling us that this could be a diffuse source pollution. That means the pollution could be coming from agricultural sources or leak pipes. So it's also interesting for us to see that there are indicators where we could measure if there is a pollution from an urban area. And usually, having these cases, having a graph like that in most cases is a pointer to what the situation of the area is at any point in time. And so these are some of the organisms you will find in areas that are good and in areas that are bad. Areas where you have high urbanization levels, you're likely to find those kind of organisms, and then here you're likely to find them in conditions that are favorable at the air level. So in summary, we've tried to discuss urbanization, looking at the impacts on the biosphere, and the challenges of abstraction, urban water transfer, land use, pollution, climate change, infrastructure. What we will now do is that for the BSc, this is what you will do as your assignment. I think it's already online for you. You will read through the paper, and then you will answer the question. The aim is not only to read the paper for the sake of answering the questions. The aim is for you to be able to read and synthesize what the content of that paper is. And for the master's degree students, I will encourage you to read it. And so there is also another paper that will give us an insight into the discussion tomorrow. I think it will be good for us to just have a look at this paper before tomorrow's case study, so that when I just speak, I just go straight on the case study. Okay? And this will also be a subject of the discussion for the MScs.
I am not from that
From that
department.
place. Ah, I see.
It will give me priority.
Well, here, what happens is that for us, we are allocated students. So you might wish to discuss with the program director,
Yeah.
because what I am given is that during for the master's degree students, they just allocate students.
Ah, okay, okay.
You might discuss to see outlining
Yeah.
your plans.
I just, but I was, yeah, I wanted to know if you were interested. A little bit
It would be
different
good. It would be good to know what is available.
Yeah. Okay, thank you.
Oh, no, no problem.
Bye.
BSc students need to attend the tomorrow lecture.
Everybody. The lectures for tomorrow is everybody.
So the class discussion.
The discussion group is the MSc students have a separate discussion session. I'm sure you know that.
Okay, okay, thank you.
But all the lectures, everybody compulsory.
Okay.
It's going a little bit fast for me, so I'm not sure if I am understanding well. So as we see the bar is declined,
Sorry, please. Let's put it here.
is that because of the water?
Yes, exactly.
Totally.
Yes, you know, it's good. You here, you can see that when the water level is high, we can see this is almost the same.
Yeah.
And then we see, but all of a sudden we see that when the discharge came low, this is the discharge, you can see it's cubic centimeter per second. We can see that here the water is low, and then that brought out the level here. So what it means is that because this has now come so low, there is a tendency that there is an influx of sedimentation. You understand? When there is a lot of influx of sediments, you understand, it reduces the dissolved oxygen. So when there is decrease in dissolved oxygen, there is also other turbidity activities taking place. There is also, some form of degradation taking place, ammonification taking place in that place. So what happens basically is that organisms that are tolerant will not be favorable of these conditions. These organisms, they are favorable of areas where we have good oxygen, good temperature, good flow, and moderate concentration of nutrients, or even standard concentration of nutrients, and that's why they survive. But this kind of flatworms, you are also able to see like other